Assalamualaikum warahmatullahi taala wabarakatuh. My name is Muhammad Syahmi bin Jeffrey. Okay, I will explain about our introduction. Okay, what is power system? Okay, the power system is a network which consists generation, distribution, and the transmission system. It uses the form of energy like coal or diesel and converts it into electrical energy. Second one is what is electric power. Okay, electric power system are real-time energy delivery system. Real-time means that power is generated, transported, and supplied the moment you turn on the switch. Okay, the prime objective of the power system is to ensure safe and reliable electrical power supply to consumers. Okay, what we have to do in this project? Okay, in this project, we have to build a power system elements behavior in practical environment under steady state and transient conditions. Other than that, we have to analyze the power system in steady state condition, identify the problem related to power system, and protection mitigation of the cost. Control of all electrical quantities is compulsory. Normally, the value of voltage, current, and frequency should be under control. And limiting these electrical quantities ensures the power system protection reliability. Okay, there are some possible protections of each element used as accessory in power system. The first one is high voltage transmission network protection. It is protection on the transmission and distribution system serve two functions. It is protection of plant and protection of the public, including employees. At basic level, protection disconnects equipment which experience an overload or a short to earth. The second one is generation sets protection. In a power plant, the protective relays are intended to prevent damage to alternators or to the transformers in case of abnormal conditions of operation due to internal failures, as well as insulating failures or regulation malfunctions. Okay, the third one, overload and backup for distance overcurrent. Overload protection requires a current transformer which simply measures the current in circuit. There are two types of overload protection. It is instantaneous overcurrent, IOC. Okay, IOC that requires that the current exceeds a predetermined level for the circuit breaker to operate. And the second one is time overcurrent, TOC. Okay, time overcurrent protections operates based on a current versus time curve. Based on the curve, if the measured current exceeds a given level for the preset amount of time, the circuit breaker or fuse will operate. The fourth one is earth fault. Earth fault protection also requires current transformers and sense an imbalance in a three-phase circuit. Normally, the three-phase currents are imbalanced, roughly equal in magnitude. If one or two phases become connected to earth via a low impedance path, their magnitude will increase dramatically, as will current imbalance. If this imbalance exceeds a predetermined value, a circuit breaker should operate. So the fifth one is low voltage networks. The low voltage network generally relies upon fuses or low voltage circuit breakers to remove both overload and earth fault. The sixth one is distance or impedance relay. Distance protection detects both voltage and current. A fault on a circuit will generally create a set in the voltage level. If the ratio of voltage to current measured at the relay terminals, which equates to an impedance. Lands within a predetermined level, the circuit breaker will operate. The seventh, backup. The objective of protection is to remove only the affected portion of plant and nothing else. A circuit breaker or protection relay may fail to operate. The last one is cybersecurity. The bulk system, which is a large interconnected electrical system including transmission and control system, is experiencing new cybersecurity threats every day. Most of these attacks are aiming the control system in the grids. These control systems are connected to the internet and makes it easier for hackers to attack them. This attack can cause damage to equipment and limit the utility professional ability to control the system. That's all from me. Thank you.
Assalamualaikum. My name is Rasydan bin Nazri. So today I will show the simulation power system in the Power World software. So in our project, we use Hadi Sadat as a reference. In example 6.8, so this is the circuit. So it consists 3 buses. So I will redraw the reference in the Power World. So the first bus is slack bus. With PU 1.05 there. Then the second bus is load. The bus is PB bus with 1.05 PU voltage. Then we will enter the generator at slack bus. This will be 0. Then the generator on the bus. The power is 200 watt. And the load. Constant power is 400. Then now the transmission line. Transmission line 1 to 2. Within 002 the resistance and the reactance 004 0.04. Transmission line 1 3 0.01 0.03. Then the transmission line 2, 3 0.025 0.0. So after this we run the simulation. So we get the number of the slide bus here. So we see the answer on the reference. So the power is 208 at slide bus and 144 HQ power. So bila PV bus will already know the 200 milliwatt, and then the Q power is 146. So after that we will we see the current flow. Current flow at transmission line, so we will know the current flow of the transmission line. So we will put all of this and the other details on the buses. So here we are put out of the detail in the circuit. So we have the ampere, megawatt and the Q power on the transmission line. For the transmission line, so we run again as a steady state. So we know all the power as the reference of the answer. So you can see here. So the result will be in the slide. So then we'll put the fault and fault analysis. The fault that we use is 3-phase inline with 50 location, 50% of the location between line 1 and line 2. So then we calculate. So we got the phase voltage of the buses, the slack, load and the PV bus. So here are the record of the fault analysis. So as you can see, here is the fault that IQ in between line 1 and 2. So we can see line 1, 2, 3, the current are changing. So after the fault, we protected circuit will do its job, and then the circuit will be open when the fault happen. So and then we run again. So as you can see, there are no current flow between line 1, line 2. Then the generator in slack bus, the power and Q are different and some of the value are different. Okay, that's all for me. Thank you.
Assalamualaikum, my name is Muhammad FAHMI bin RADUAN. Today I will present about result and analysis. Firstly is steady state analysis. On the left is power system that we have choose on hadis adab book, and on the right is power system that we have built on power wall. Okay, this power system consists 3 buses, which is bus number 1 is slack bus, bus number 2 is load bus, bus number 3 is PV bus. Okay, our system, our S base is 100 MVA and V base is 240 volt. Okay, this is our result. On the left is bus data result. Okay, as can we see, the result on simulation and reference is bit different. For example, like this, 0.97 angle of 22.7 and 0.97168 angle negative 2.6948. Okay, as we can see, the result is bit different because in power world have different iteration. Okay, this table is current value in per unit for transmission line. Okay, transmission line transmission line Y12, this one. Okay, the current is in actual value, so we have to convert it to per unit because it easier for us to do the fault analysis, because some value in power world have actual value and some have in actual in per unit, so we have to convert by using this formula. I base equal to S base per cert 3 and multiple by V base, and per unit is actual divide by base. Okay, that's all from me. Thank you.
Hello and Assalamualaikum. I am Muhammad Farhan bin Muhammad Farid ROZAIDI. So I'm going to explain to you about fault analysis. So as you can see, we choose our fault happen in between the first bus and the second bus. So this is the fault bus. So we assume fault bus as 4. So as you can tell, the value of voltage change after fault occur. So for slack bus, from 1.0 to 0.8578. So for generator bus, 0.97 to 0.4623. So for load bus, 1.04 to 0.1957. So for bus fault in steady state, initially it wasn't exist. So after the fault, so the voltage becomes 0. The phase angle is 66.47. So for transmission line also change after a fault occur, from Y12, initial value current is 2. So after fault, the current becomes 0. Y23, the initial current is 2.81. So after fault happen, the current decrease to 2.26753. So on, Y13 from 0.4 ampere to 0.75226. For bus in between Y14, initially there's no current because from bus 1 to bus 4 is the fault. So after fault, the current become 3.83616. For transmission line Y42, initially there's no current, so after fault is 2.06729. Okay, next I'm going to explain about protection analysis. So as you can see, this is our system after the protection is applied. So as you can see, we put a circuit breaker in between bus 1 and bus 2 because the fault is occur in between the buses. So as you can see, this is the value that I will tabulate after the protection we applied. As you can see, the value is back to normal after the protection is applied. During the fault, the value is decreases. As example, this slack bus 1 for the voltage originally in steady state is 1.05, then after the fault occur it's become 0.08578, then after protection it's back to 1.05. So next, this is the current value for each transmission line when the protection is applied. So during Y12, so the steady state is 2.05 and the fault is 0, but we also get the current for protection in Y12 also 0 because there is no the circuit is open. So for Y23 is 2.18 and the fault is during fault is 2.26753 and during protected it's increased to 5.18. And for transmission line Y13 steady state in 0.4 and it decreases during fault 0.5228 and after protected it increased back to 2.297. So next, transmission line for Y14. So in steady state there's no fault bus, so the current is 0, but during the fault there is current, it's 383616. After protected it's become 0 again because the fault is destroyed. So next, Y42 steady state, there is no current in between there. In fault 2.6721 and protected, so there is no current also because the fault already protected. So that's all from me. Thank you.
And Assalamu alaikum. My name is ABDIWALI MOHAMED and I'm doing now my part of the project. My part is the question that the doctor was give us last week and the conclusion. And the first question is, what software did you choose? And we choose Powerwall because Powerwall simulator is an interactive power system simulation package designed to simulate high voltage power system operation. Advantage of software. Advantage of Powerwall software. And the first one is created by a skillful and talented person or engineer. High reliable, and third one is helpful because become more flexible. And the limitation of our project is, and the first we are using for to disclose many hidden errors, but this methodology never guarantee the absence of error. Second, testing cannot be done against system requirement, and we also cannot detect any error in requirement or ambiguous requirement leads to complete testing process or inadequate testing. And the last one of the question is, what makes a good protection system? The good protection system makes principle of various power system protection relay and scheme, including special power system protection scheme like differential relay, restricted earth fault protection, and directional relay and distance relay, and so on. And the last one, conclusion. As our conclusion, we are are able to be familiar with power system elements, behavior in practical environment under steady state and transient condition. Besides, we can demonstrate the test system models of power system and using software of power world. Other than that, is some value in a power wall in per unit and some value in actual value.